proud to announce the first ever winners of the Brain Prize. The 3 recipients are all from Hungary. Tomasz Freund carries out his research in Budapest. Peter Somogyi is currently situated in Oxford, England. And György Buzsáki works in Newark, in the United States.
Cerebellum is a parallel computer because they are doing their jobs, the different elements, independently. Now the neocortex and the hippocampus are organized totally differently. The whole idea there is that whatever is computed locally, it's broadcasted globally. And whatever is the global state of the brain confines what goes on locally. And so if this is so important, then the structure is that it serves must be different.
And in fact, all 3 of us had very early pioneering inspirational work of an international collaboration, just like now ours is. From János Szenketágotai, Sir John Eccles and Masao Ito published a pioneering book in 1967, The Cerebellum as a Neuronal Machine.
I think the other reason why they did not directly collaborate was because the techniques were not yet available that allowed the joint structural and functional analysis of these circuits. These methods became available during our studies, and some of these approaches were in fact designed or developed by the 3 of us. And namely, this is the possibility to structurally study and identify neurons that were previously studied electrophysiologically in the normal and living brain.
I first heard that I'd won the Brain Prize just after I got home from a long trip to California. I was very jet-lagged, and I had this call explaining that I'd won the Brain Prize, and it was a most astonishing moment.
So far we have been very much concentrated at the peripheral level of the auditory system, and we are still deeply involved in trying to decipher the molecular mechanism of hearing, especially how do we perceive some sound, how the brain is able to integrate the various harmonics of sound.
We've had a very wonderful opportunity to work with strange, rare, and fragile organisms that make these optogenetic tools.
Optogenetics has 2 key ingredients. One of them is genes, and the other one is photons of light.
There are many promises, let's say, in a certain sense, that you can do almost everything with optogenetics. But one point which is very much in advance is the recovery of vision. When you lose your endogenous photoreceptor system in your eye, you can replace it by these microbial rhodopsins.
Then we also had the luck that we made some mistake with the solution. So the solution was very acid, and because with this acidic solution I suddenly got real big signals.
Well, it means a very great deal to me to be a Brain Prize winner. As I've said, it's an overwhelming and delightful experience to have had this announcement.
One of our projects that we have started just now is to record neurons from humans. The technique is to implant electrode and then the patient for 5 days tested. We modified slightly these electrodes, and now we can record not only the basic electroencephalography, but also single neurons. So in this way we enter really in the mind of the person.
So what we found is that some abilities are foundational, and in fact they are extremely basic, such that they are found even in young infants and even in non-human species.
It's very interesting. It's perhaps less than 20% of people who abuse drugs actually become addicted to drugs such as cocaine.
It's a wonderful period to study the human brain. I feel so lucky that we have all these techniques. We have brain imaging, the brains become transparent. We can study it in incredible ways. We are solving philosophical mysteries that have baffled people for hundreds of years. So for me, it's a sense of excitement, and having the support of the Brain Prize is wonderful, gives me a wonderful sense.
Getting these prizes, of course, is very satisfying. It in some sense shows that one made the right decisions 20 years ago or 30 years ago in what to work on.
Actually, we started out with camera imaging, with confocal imaging. And in 1990, when Winfried Denk and his colleagues described two-photon microscopy, we immediately realized that this is now really maybe one event that may initiate a small revolution in the way how we describe what happens in these processes.
We had a computer projector which through a special mirror projected an image of the virtual world onto this screen surrounding the mouse. And this virtual reality system, we started examining whether or not we could image neurons in areas important in navigation during awake behavior.
But with two-photon, you can also not just look at large groups of neurons, but also at the connections between neurons, the synapses. And I think two-photon microscopy will have a large role to play going forward in our efforts, in the community's effort, in trying to understand how memories are really encoded at synapses.
I consider these prizes less of something that will improve my research, but it's something that provides an incentive for others.
For me personally, it means also that it allows me, hopefully, to prolong my time in science a little bit. Yeah.
It gives us recognition. It takes some time away from my research. Hopefully not too much.